Today we're going to talk about one small piece of code. Particularly, is a very important topic because it infuses a couple of items together. How to read files, which you already have a video on that. How to write files, which you also have a video on that. But what you don't have in a video is how to generate random numbers. It's very easy, and I'm going to discuss that today. But I want to make a small task that will help you to understand reading files and writing files in the same piece of code. That's why I decided to make this video that allows you to basically combine those things together. If you check the back of the book, there is one prompt similar to that, but it doesn't infuse everything together. It shows you how to generate random numbers. It will show you how to read files and how to write files, but not together. So in this application, I will do that. And the reason why I'm showing you that is because you have a new lab that is going to be very similar for what we're going to do today. So let's go ahead and start. And let's start with the presentation real quick. As I mentioned, we will talk about how to process files with random, right? Now, random, it's basically a random number. Now, we'll talk about the advantages and disadvantages to have random numbers, but we'll talk about random numbers, read and write files. So random numbers are very useful in computer science for many different applications that we use randoms. So for example, when you want to simulate information that kind of behaves under certain ranges, we use random, and that's because we want to avoid just keep asking information, or when you don't have the data, we can just use the data randomly. It's called synthetic data, but it's still randomly used for different purposes. Cybersecurity is one of the important aspects, in particular cryptography. And cryptography uses a random numbers, and not only crypto, but every time you want to test specific items or basically create a basically password, a random password, you generate the power of random. It's another thing that we use. And of course, there's other things that we can use for probabilities, testing, and development software. So that is why we're going to introduce random numbers. The, the books provides a very small piece of code that relates to this. So, but there's different forms to generate. In particular, we're going to talk about two things: the math are random and the random object that you have in your book. So we're going to demonstrate this by using a task. The task is to generate a file containing 10 random numbers between 0 and 20. So we need to, first of all, generate that random file, then read the file containing those numbers and make the square root for each of those numbers that you find in the file. When you're done, you need to write the results in a file called output.txt that will contain the original numbers, let's say x, along with the square root numbers y. And you need to write a statement that says the square root of x is y. So that is the task that we're gonna work today. I'm gonna break this whole task into small pieces so you can start to generate a couple of algorithmic steps. And the reason why I'm gonna do this, I'm gonna repeat myself here, is because there's coming some labs that require this mechanism, this mindset about how to process input files and process output files in the same piece of code. So let's demonstrate that. So what you see right now, I've just created a file called process random files example. So I'm going to incorporate scanner because we need to read from a file, but also remember that every time we process any kind of files like reading files or write files, we need to import a library called java.io.star wildcard. Because we're reading a file and writing into a file, we need to have the input output library that you can see in line 2. And let's see, public static string args. And we need to incorporate the throws IO exception. I'm going to copy and paste the task. Oops, well, the task is too long. So generate a file contain 10 random numbers between 0 and 20. That's the first thing. And then read the file and perform the square root for each of the numbers from the file. Finally, write the results in a file called output.txt that will contains the square root and the original. So this is the task. Now, I recommend to do this all the time. Just copy and paste the task there and start to break it into code. This is kind of important for you, for your development as a programmer. Here we're going to introduce a lot of concepts, like including what's your input, what is the desired output that we want, and what exactly we need to do. So the very first step is to generate a file containing 10 random numbers between 0 and 20. Now, how do you generate a a file? You can create something called print writer, as you can see in the other videos. I'm going to call it print writer, PW equals new print writer. And for this one, I'm going to call it input.txt. I didn't specify that in the task, but you need to have a file that generates 10 random numbers. Now, generating 10 random numbers can be done in 10 different lines of code. I understand. Or we can use just a for loop. Do you agree? We can create just a simple loop that runs 10 times, as you can see here in line 7. That will generate 10 numbers. Why am I using a for loop? Because right now we're doing 10, but later on, maybe I want 20 or 23 or 31, maybe 54, 107, maybe 7,034 or 1 terabyte. So I'm not gonna come back and just copy and paste that a lot. Instead, I'm gonna do a for loop that allows me to basically run it for 10 times. And in the meanwhile, you can just generate them. Now, remember that every time you write a file, PW, you need to close it. So I'm gonna do that right away. I'm gonna create it and then close it, and in between, I'm gonna process something. Here's where I'm gonna generate the random numbers. So there's two ways, or two common ways to use random in Java. I'm gonna show you something that is not in your book that is very effective. This is called math.random. Math.random, ladies and gentlemen, generates a number, and actually I should just put it here. Let me see if I can see the description. It will generate a uniform distributed number between 0 and 1. I'm not so sure if you can see this in your screen, but in my screen I can see clearly that it's showing you here the description. It returns a double with a positive sign, greater than or equal to 0.0 and less than 1.0. Notice that the 1.0 is not included, it's not inclusive, but the 0 does. That's why it says greater than or equal. So a couple of things here. One, it generates a random number between 0 and 1. Second thing is a double. Probably I didn't specify in our program, but it should be maybe, I'm not so sure, positive, integer, or whatnot. We didn't specify. Math.random generates some random numbers between 0 and 1. So we don't want that. We want to expand it, because here is asking between 0 and 20. And because this piece of code generates between 0 and 1, we want to enlarge it. So in order to scale it up, we need to multiply times. If we want to include the 20, we need to multiply that times 21. Why 21? Because remember what the description says on math.random? Math.random generates some value between 0 and 1, not inclusive 1. So if you want to include the 1, you need to go 1 extra. So that will be to multiply times 21 to generate the 20. Now, if we do that thing, we're gonna generate that number. It's a double number. And what I can do here, just before we do the writing file, I can do system. So you can see what we're generating here. System of parent line, that random number. Let me go ahead and test it. If you can see, I'm not so sure if you can see or appreciate the output. There's 10 random numbers that I generate there. First one is 8.652317, all that, 5.98, 1.12. So this one is small, 0.2267. So there's 10 random numbers. Even if I generate again, if I run this program again, I will generate another 10 different random numbers, another 10 different numbers, another 10 different random numbers. So we have those different random numbers that we generate, as you can see. Yeah. So, and that's, let me see, we didn't include 20 here. Can we? Oh, here it is. So here we have 20.46. We include that, but this will not generate, oh, there's another one here. This will not generate 21 because we want to include 20. That's why we went all the way to 20. Now, we don't know if we want whole numbers or double numbers. Here we generate random numbers. Now, there's a trick to just generate whole numbers. And this is by whatever you got in this part here, we're gonna basically typecast this with an int. We remember this from the very beginning of our sessions. We basically typecast with the integer. Here you're forcing Java to basically transform whatever you have in the right hand side, which is a double, force it to transform it into a number, an int. So you're forcing it here. It's called typecast, and that is okay to use it as long as you know what you want. I'm just gonna clear my screen. I'm gonna compile this part and run it here. So can you see now that we generate just random whole numbers? That's one. Let me just do it again. That's 2, another 10, another 10. You see? So I'm generating. Now, if you want to generate more than 10, maybe 100 or 1,000, you can just put there and don't worry. This will basically perform the same operations, but 1,000 times in this case. Are you ready? Boom. So here's 1,000 random numbers between 0 and 20. Wait, did I save this file? No. Wait, this is not 1,000. Are they? Oh yes, there were 1,000 there. Of course, there's a lot of repetition, obviously, right? Because you're gonna start generating 1,000 random numbers there. So this helps us to do that. Very impressive, very, very exciting to do that. Let me see if you can see my screen. You cannot see my screen, but you can see the application screen only. So at this point, we're just printing. So we're demonstrating by printing. But in reality, we don't want to print. We just want to write. So we're gonna see p print writer dot print, and then let me see if I have there. Yeah, there's a print line. We're gonna print line R. So what is R? R is for random, it will be this whole thing. I'm gonna generate the random number. Excuse me. We're gonna generate the random number. We're gonna store it in R, and then we're gonna print it in our file that we just create on line 6. We're gonna continue doing this. Let's be considerate. Let's just have 10. So that's that. Okay. And for this purposes, I'm going to share my screen, not my application. So I want you guys to see what happens. So at this point, you can see, I'm gonna remove this part. I'm gonna remove these two files. So you can see this file that I'm generating right now. Yeah, process random files in my desktop. And what I'm going to do at this point, I'm going to save my file, compile it, and then run it. When you compile, I'm not so sure if you noticed, but I generate the process random file class. Yeah. Many of you have sent me this file. I don't want this file. However, this is the file that generates or help us to run the programs in your computer, but please always send the .java. So I'm gonna run this and look how magically is going to have to generate another file called input.txt here. You see? Input.txt. I'm gonna preview here and I generate 10 random numbers. I'm not so sure if you can appreciate them in the screen, but there's 10 random numbers: 6, 0, 11, 8, 12, 7, 6, 10, 9, and 2. Whole numbers. So that's the first part, generate a file containing 10 random numbers. The second part is to read that file that we just create and perform the square root of each of those numbers in the input file. That's the second thing. For that, we're gonna create scanner. We already have a scanner here written in the past. So here we're gonna read the file called input.txt. So in this program, we generate that input.txt with 10 random numbers, and then we're gonna read it again. Actually, we never read it before, so this is the first time we're gonna read it. And what we're gonna do in the meanwhile. So let's test this. So while the input dot has next, you probably remember this from the videos that I show you or in the chapter. Well, there's more stuff to read. We're gonna read numbers, and I know I show you an example next, but I'm gonna show you example with because we already know that they're only numbers from our file. They're numbers. Then we can safely say, you know what? Give me the next number that is in the file input. I'm gonna extract the next number. Here it is, the next int. So next int will give us an int. We're gonna store it in n, and check this out. What's gonna happen? We're gonna generate SQ. S is for square root. So we're gonna call math.sqrt of the value n. Okay, so we're gonna do that. And before we write into a file, let's test this thing. Let's create system.out.println, a string saying something like, what was the output? This one. Maybe to be consistent with the instructions, what I should have done is that this guy should be called X and this should be called Y, just to be consistent with the statement and instruction. So X is the value that I get from the file. Y is the square root that I'm performing with the value X. So the square root of X, here I will put concatenation of X. And here I'm gonna put concatenation of Y. I'm just gonna put the dot there for simplicity purposes. All right, this is what, let's try this. Oops. Sorry, this should be X. Ready? So if you can see my screen, I'm not so sure if you can see my screen that big. So if you can see, I have the square root of 15 is, and then the square root. 4 is 2, 12 is 3.46, and so on. So I graph each of the numbers generated that were generated in randomly in the file output.txt, and then I perform square root by using math.sqrt. It's pretty cool. Yeah. So if you don't believe me, here's input, and here are the numbers. So this is 15 and 15, 4 and 4, 12 and 12, all the way 15 and 15. So each of those numbers, you get calculated the quadratic, I'm sorry, the square root. So we're almost done. The next thing that we have to do is to write the results in a file called output results.txt. So we have that name, and that's no problem for us because we need to write this into a file. So we already know how to do this. We create a print writer. I'm gonna call this output, goes new print writer. I'm gonna put the name of the file, which we already know. This is output results.txt, and I'm gonna close this. Okay. So don't forget to close output. This is some kind of it's a best practice. Every time you open an print writer, close it somewhere. Yeah. So we already wrote most of the program because the file that we're gonna write basically belongs to what we just did. But here we're printing. But instead of printing, maybe we should do this: output dot print line. That's the only thing I change. Everything remains the same. So again, line 14, we're gonna read input.txt file. Line 15, we allocate a piece of memory where it's gonna be responsible to write files in the results of the files. From line 16 to line 20 is the typical while loop that we basically use in order to navigate through the entire file. And instead of just printing what is in the file, we can extract the number, we're gonna store it in X, and then we're gonna perform some mathematical operations. In this case is the SQRT, which represent the square root. Line 19, the only thing that we're doing is we're reporting back, or we actually writing into the file X, value of X on line 17 and the value of Y in 18. When I compile this program, nothing is going to happen with the files that we have in my desktop. I left my desktop here so you can see how they behave. But when I compile and run, then you will see an extra file called output results.txt. Inside, we're gonna have the result that we just got in the screen from the terminal, but in the file. Check this out. The magic appear, right? I use the word magic because if you show this to Granny, Granny's like, oh, this is sorcery. Or, but no, not Granny, this is software engineering. But of course, Granny's a hacker. So output results, if I open this file, you will find the actual results that we have from the square root. So the square root of 2 is 1 point, etc. You can read this part. So the purpose of this task is for demonstrate multiple processes you can have in the same program. You can generate a file, but you can also read a file and write into a different file in the same program. The random was just an excuse to demonstrate this file processing. But randoms are also important because that will generate a lot of different things. So let me just give you a variation of this using the class random. And here you can see my screen. This is the way you can create random um, in case you are interested to see how this works. The book gives you a very nice way to do it. But there is a couple of other stuff here where you can use you can use. For example, we're gonna use next int, which will return the next pseudo random uniform distributed in value from random number generated sequence. So before going there, we need to create a constructor. So we need to use random, and I'm gonna use this one. So the seed will be the initial values of internal state to random. So this is the way we can usually do it. So how does that change here? So instead of just using the R here, we can create random R, new random. And here we can put 21. And you know what, I should not call it rand because R was the actual value, random. So just gonna call it random. And I'm gonna create R, which is rand dot next int. Actually, yeah, so here's where the 21 goes. You can just do this one. So notice what I'm gonna do right now. I just uncomment the one line of code and I create this too. Let me see if this compiles first of all. So at this point, it should be generating another file, output results. And you can notice there are different random numbers, of course, they're called random. But if you notice here in input, there are random numbers also between 0 and 21. Let's generate another file. I want to see if we can different random numbers. I want to make sure I include one with 20. There. Okay. We generate a couple 20s. So there's two different flavors. If you want to do the random way that the book explains, nothing wrong with that. But to be honest, I don't really use this too much because, I mean, look, check this out. I have to generate an object, invoke the method, and also I'm incorporating the wildcard here, but you need to include that. If I put here scanner, this program will not run because here I'm only importing scanner. Check this out. I'm gonna clear my screen. I'm gonna compile this program, and Java will complain. It's going to tell you, hey, what the heck is random? I don't know what random is. And the reason is because we're not including it the same way we include with the java.io. If you want to include random, you have to import that library. And there is no problem by using java.util.random. You can generate random, but notice that I'm incorporating more libraries. And there, for example, here now you compile successfully. But that's because I incorporate random and scanner. Both of them are in the same library. I think in the past I did a scenario when I can just include the star, which is called wildcard. Just you put them together. So the star is called wildcard. So that gives me everything. So that includes both scanner and random. But again, the disadvantages is that the random object, you need to import that library. You need to create a file. I'm sorry, not a file, a random object, and then you need to invoke that. and nothing wrong with that. It's fine, and that actually gives you more practices with object. But look how elegant it could be, just one line of code versus all that drama. It's really up to you. I'm not picky on this. Yeah, I use math.random because I'm old school. So, but you can use the other ones because it's in your book, and I think it's kind of nice to work with objects that way because it gives you more flexibility. And when you're dealing with more complex solutions for probabilities and whatnot, maybe random is more useful than math.random. Okay, but that again, this is only an excuse to show you or to demonstrate how they work in Java. So if in case you have any questions, please let me know, and I'll be happy to elaborate that in our next assignment.